Hi guys, welcome to our little SnapGene tutorial. We're just going to talk about how we look at our primers on our sequence. So hopefully you have your sequence that we pulled from NCBI, right? Your 5' UTR and a bunch of white stuff. We said about 1,000 base pairs or a little more. So this is my example. Remember, SnapGene shows us both strands, so we just pulled that one strand from the 5' end. So this was in the white, and then as we went all the way down, right here is my first ATG. So this was where my 5' UTR was. I should annotate where that actually is, but I don't have that right here. But I know I'm really close to the first ATG because there's the first ATG. So I copied my sequence in. So if you don't have a SnapGene file yet, take a pause and go set your guy up. If you're ready, we are going to come down to the bottom, see where all these says map, sequence, enzyme, features, primers, hit that. And we are going to just start typing in a primer. So what else do we need today? Well, we need the sequence of our primers. So hopefully you saved those somewhere. You took a screenshot or you copy and paste it into a Word document. If you didn't, I know, we all did. If you just have a screenshot, you might want to copy and paste it into a Word document. If not, either way, it's all good. So I'm going to show you mine. So here is my detailed primer report from when our reverse that we made ourselves, and then we asked the computer, NCBI, Primer Blast, to make our forward. And remember, if you don't remember, I got a bunch of primer pairs, and I looked at primer pair 2, and I also looked at primer pair 4, and I liked primer pair 4 because, right, it had the lowest self-complementary on this side. This is the primer I made, so this is the reverse, and then this was the one that the computer made. And so both of these, this one was 512, primer pair 2 gave us 541, but its self-complementarity on the 3' end was not as good. Here's a 2, we had a 0. They both were kind of stinky on self-complementarity. It is what it is. We're going to go with it. And so these are my 2 primers. And so what I did, or what I'm going to do, I'm going to highlight my reverse primer. I'm going to copy, and I am going to paste. Maybe. Add primer. Paste, add primer. Add primer, add primer. There we go. Paste. And it shows you where it lines up. Yay, it's right here by that ATG. So we're going to say, okay, copied the correct one. And I'm going to add the primer to the template. And then I'm going back. I want to get my forward primer. So I'm going to copy and paste that guy. I just highlighted them yellow so I'd remember which pair it's doing. Take a copy, come back over here, go to my pull down menu, add primer, paste, and right, you have to make sure you're 5' to 3', and there it is. That's where that guy sits. Looking good. Add primer to template. So now here's our information about these primers. Tells you where they bind, right? So this is my 3', my 5'. How many nucleotides? And today I added it. All right, so now if we go back to the bottom and we go over to our map and we click map here at the bottom, it gives you a map. And what it's showing us, here's that whole piece, right, to the 992. So if you hover, it'll tell you where you are, right? Ooh, it marks my 800. And so if you're in between, you can tell exactly where something is. So these guys over here, these are restriction endonuclease sites. So for example, KPN1, if I wanted to know where it was, right, I would just hover over here. Well, it tells me right here, 716, right? But there, that would be where it is, right there. It's showing us the primer. So here's my forward primer, and here is my reverse primer. right? So he's facing this way, he's facing that way, and then this is showing us the restriction enzyme sites that would be within my insert. And then these guys won't matter because I'm only going to be amplifying this. This is all that's going to end up in my PCR product. It's going to be 512 base pairs long. Yay. If we want to look at it another way, we can hit sequence down here at the bottom. And there we go. There's our 5' primer. So remember, this was all the sequence that we plugged in, that 996 base pair piece or whatever I copy and pasted. And primer 2 sits up here at, I was hovering, 478. And all the way down to right next to that ATG at 991. And so if we do that math, it's going to come out to be 512, 513. So that's the piece between the two primers that is actually going to be amplified. And that's what we'll want to clone into our vector, which would be our next step after we do the diagnostic electrophoresis gel. So the other thing we want to remember is not only the size of our little piece that we're going to PCR out, but if we're planning to run an agarose gel, then we need to know about mispriming. So remember when we did the primer pair check? That's what that's for, to see where else it might sit in the genome. So let's scroll down. I copied it into the same file. So I did a primer pair check. I did primer pair 2, which I didn't choose, so we're going to ignore that. And so primer pair 4 are the ones that I just copied into SnapGene. Those are the ones we're going to do PCR with. So it's just all the same info. And then it shows you where it's going to sit. This is on itself. Good. We want to make sure it sits on itself in the genome. So all of these guys that are the immunoglobulin locus, that's all my V-pre-B guy. Okay, so this is me, this is me, this is all me. Aha! Here's one. That is not me. So it's possible, there's mismatches, you can see the mismatches, but it's possible that my primers can sit down on this region of a chromosome and give us about 1,088 base pair piece. Okay. Here's the same. Oh, it could misprime again. This one's 4,300 base pairs. That's pretty big. I don't really have to worry about that. 4,330. Here's another one. 2,500. Aha. Here's another one. The 905 and the 902. So those are going to be closer to my 500 base pair piece. So I just want to make sure the agarose that I choose is the agarose for the job. What percent helps you resolve the two fragments. And so we'll talk about gel electrophoresis in the next tutorial, but just wanted to have us remember. So my piece over here, the 512 guy, right? We'll go back to our map. Right here, this is what I'm amplifying. That's what I want. But my gel, right, I might do PCR off of some other stuff in the genome, and I could get a 900 base pair piece, 2,500, 4,300, and this about 1,000 or almost 1,100. So I'll be on the lookout for those. If I have multiple bands on my gel, I'll know which ones I should expect and which ones I shouldn't. So that being said, set up that SnapGene so you're ready, check out your mismatches, and we'll be ready for gel electrophoresis. As usual, thank you guys. Totally appreciate it. See you soon. Hey, it said I was not recording. It's still recording.